Morning.
Morning.
Hey, good. How are you, Tony?
Welcome back, David. When did you get back?
I got in last week. Yeah, this week has been busy too. So, yeah. Let's give everybody a minute or so to join.
Yeah.
In the meantime, I'll find the email from Bala and I will share it.
I'm sorry. What did you say about Bala?
I will find the email from Bala, the one he sent out after the last meeting with some of the proposed pin properties. Okay, here we go. I hope he can join today. Okay. Yep. Okay. I found the emails. Let's give everybody a minute to join. Is there lots of background noise coming from my line, by the way?
No, sounds fine.
Okay, good. Okay. Bella.
Hey, Tony.
Yeah, hi, Bala.
Hi, David. Everybody.
No, it's the other way around. I'm David and Tony he's Tony. That's okay. Okay, maybe we should get started. Bala, I wanted to actually thank you for sending the email with list of pin properties. I have some questions. I was wondering. Let me actually, let's do it like this. I'll share the spreadsheet which you sent out, and I will also take notes about some of these properties. But that said, do you want to walk us through the overall thinking about these properties? And I'll have some questions about some specific properties later.
Okay. So these tables, right? I have summarized based on the different tools how they will interact with the DFT pins. So basically, I have grouped based on the applications. The first table that you see, I have taken a common set of pins where the clock, that may be the scan clock or the JTAG clock like TCK, and with the direction information, it's the input direction. And then there are signal group and waveform period, waveform sequence. So these three attributes are used for the vector translation, which are also covered in any ATE vector formats like style or wiggle. So so all those formats need these attribute sections so that they can define appropriate timing attributes for the tool to handle, either to generate the clock waveform or to apply the inputs. If it has to apply the inputs, it needs to also know that in relative to the clock period, like what is the relative period, and also for the strobe window, right? So that will be the strobe window will be adjusted for the ATE for the pin margin. Like so, ATE guys again they will do some more fine tuning and adjust that in what the timings needed for the arrival um, and for the strobe and the input forcing type of applications. So those informations are the placeholder. So I have given a specific examples for each of the cases. For the clock, at the minimal, we need the clock period, which is the column D, like column D and the row 4.
Yeah.
So
Yes.
there is a 10 nanosecond, just an example I have provided. And then the waveform sequence, this is like drive 0 at 0 ns, and drive 1 at 1 ns, and then repeat this at the with a 5 ns interval so that it
Okay.
matches both positive and negative um, forces and that clock pin, and that is the way the translation tools create the clock waveform. And then it also associate that clock waveform with a signal group attribute. It's like just I have put as a WFT underscore tap or WFT underscore clock. And so this will be a relative uh, section for any synchronous clock groups that if you want to have it. Like let's say they have a design might have multiple scan clocks, for example, so they can alias all those clocks under this signal group so that the tool understands it has to synchronously toggle all those pins across the patterns.
Okay.
Right? And so that is one example. And similarly, like for the reset, we want to force 0 at one period and then release at force another opposite value in another period. So that is another example. And then the scan in and scan outs, like at what time related to the clocks you want to force it, and then what time you want to do a strobing, right? So of so these examples are given based on the um, just arbitrary values, just as a placeholder.
Yeah.
So that way, when we give this as an example, I thought this may be more readable and understandable for the users to
Yeah.
appreciate what is the intention of this particular schema of this CDXML, right?
Okay.
And
Yes.
so I, like I have extended the same analogy for the other tools. Like so, because we want to have interoperability across other tools like thermal or stress repellent tools. So which would need based on the spice simulation results, like the pad owners will be able to tell, or the pad data sheets will be able to dictate what's the max temperature without breaking this particular pad in the usage model, right? So that they can tell us, and also what's the temperature derating factors and the maximum stress, like maximum number of cycles we can recursively utilize these pins for the forcing on or the strobing without degrading the performance of those pads, right? So these are the data available in the data sheets. So, but when we want to have a interoperability and to avoid user errors across the derivatives, like the product data sheets has to be translated to the YAML and it has to be fed into the tool.
Okay.
Right? So that is for the second table. And then the third table, similarly for the power domain and the voltage rails, right? So each pads are having the reference voltages based on a specific VDD domains and as well as power domain, right? So which groups typically, like all the GPU pads, I presume it is comes under common power domain group or based on the functional partitions, like how they wanted to partition. So they may have some um, retention voltage capabilities and things like that based on which domain is active and which domain goes to sleep. So there are multiple considerations for the power, but we don't have to delve into all the details. But we need to have a placeholder like which power domain and which voltage rail this particular pad belongs to, so that this becomes a um, off the hook information for the ATE test program development teams, so that when they get the access to the for any DFT patterns, and these power domain details are not there in the patterns. So this will tell them how they want to group all the voltage rails, the different voltage rail pads for the any given functional test, and so that they can smooth if they want, when they want to smooth or do some any characterization test like Fmax or Vmin search, so they can toggle or tie these appropriate voltage rails which are dependent on those pads um, into the their variable equation in the smooth plot test method, right? So that way, this is a must to have today. Like the ATE guys, they come to the DFT guys and DFT and physical design teams, they coordinate together and then try to create such Excel sheet so that which of the voltage and pads, which of the power pads needs to be tied together for the any smooth purpose. Right.
Okay.
So yeah. So
Yep.
this also again will be there in the data sheet, but sometime that may be an overlook or any documentation error where there may be incorrect sampling of the smooths or data, things like it might happen. But having this upfront dictated through the interoperability tools, like so this will avoid any such user errors or documentation mistakes, right? And then
Right.
this is I have just arbitrarily provided like a test power domain, core power domain, scan power domain based on whatever the like application of the pins. So I just given some arbitrary power domain names which are already available in the UPF, which can be leveraged and then extended into this particular CDXML schema through the interoperable tools. And similarly for the high-speed power domains, high-speed IOs, where there'll be HBMPD, for example, for
Yeah.
the UCI. So just a placeholder name and the values are provided. And so this, again, the voltage domain, there are different applications, especially the wireless chips, like they have multiple voltage levels, like they call min SVS, SVS, nominal, turbo, super turbo. So each level's spec has like a kind of 5 to 10% differences, and so which are applied for the multi-voltage synthesis and as well as physical design. And this, so all the cells are characterized for this uh, level spec, and there is appropriate frequency target for each of those voltage domains right across the internal PLLs and the respective sub-clock domains, right? So those all those informations are also available in the PD database. So which upon provided and this will again, which is a very crucial information for the test development flow, right? Where when the test engineer cooked up all the scan patterns or TFT patterns, and he would have to assign the voltage levels for he will replicate all the patterns across these spec voltages, and so be a installation sequence for the different clock frequencies, which are also delivered separately. But the actual data patterns, the DFT patterns, when it is separated out of the installation patterns, so then that becomes the repeat patterns. It's kind of a preamble, and then the the late preamble, the actual payload patterns can be utilized and it will be stitched in the test program, and and then the voltage levels are applied and the test program are based on what installation frequency domains are chosen. Um, so both has to tie together, and so there are today lots of manual handshake uh, meetings happens. Data manual data handshake is done, and so people take notes and develop this, and then have some post reviews, and so then people sometimes find some manual errors, and then they go through the lots of reiteration with the updated thing, right? So whatever the you collect data collected so far with the down sampling or the high sampling, like so it's our lost. They have to repeat that efforts and the ATE screening, right? So this is also again another crucial piece of information for the even for the production testing, like so to avoid any user errors. So the CDXML, this particular schema can help and uplift any such error situations. It can give some more robust methodology for the ATE guys. And the last one is like a parametric test. So today, so parametric tests, all the pads are characterized, at least for the first evaluation device. Um, this may not be applicable for the production patterns, but the initial wafers or the initial device bring up, which will go through this parametric test to check that input and output lows and high voltages to check that the parametric characteristics of this particular pad to make sure that the iterations are proper and it is meeting the spec across the different ports. And this I have given. This need not be like just the scan ports or the JTAG ports. I have given carried over the same explanation here, but this is predominantly involved for more of a functional ports. And also similarly, like for the high-speed IOs, there are a number of things that we can do. I just given um, some arbitrary informations like yeah. So if you go down the line, then there is some more information regarding the pad in terms of what type of technology the pads are involved, like how the pads are designed. Like there are different IO standards and signaling um, is involved. So this is very deep down into the pad designed by as such, but carrying out this information also will help to develop some automation and tool checks for that particular technology pads, like if there are any corner cases.
Is this all the pads or just the test pads?
Okay, so here I have listed just the clock and reset and the DFT like scan pads and JTAG and the high speed IO something like. So I have not listed any GPIO functional pads here.
Okay, so it's strictly test. Yeah. Okay.
Yeah. Just from the testing and how all this information will be valuable for the vector translation and the ATE testing, test program management, and also the production flow across the characterization flow as well, right? So all these informations are driven based on physical design sign off results, and as well as some of the data sheet informations, right? So so this is I have tried to summarize based on the exposures and where we have got hiccups and some of the information how we back traced it and found out from the physical design databases. And so this were all done as unplanned activities from the DFT perspective, but this is supposed to be planned from the ATE teams. But in certain companies, the ATE teams and the DFT teams are not coming under the same management. So one is comes under the production management, and so they are in a different project. By the time the tape out happens, they are not ready to absorb in all this information in talking to the physical design team. So they try to bring in DFT teams and channelize through us. And some of these information also the DFT team cares in terms of running this timing JLS, debugging it, and and then getting that proper SDC, SDFs, and so these are lots of details involved, and which are buried into the cross-functional teams under the scope of different management teams, right? So having this type of superior CDX ML schema, like so that will upfront bind all those interdependent attributes, and when it is put into the tools, and when tools are writing out that CDX ML, so there is one super tool can read in all those factors and then merge it and create a final checker, and that can become a sign off for the DFT pattern deliverables or even ATE program deliverables, to make sure that the end to end from the data sheet to all the way to the patterns on the test program. So everything is aligned as per the expectations.
Bala, who is the intended consumer of this information?
Yeah, so that's where I had put in one separate table. Like there are 6 or 7 groups are involved. Like so, pad design is the last one, and then the previous one is the parametric test. It's a characterization team, and then if you keep going further up, so each table has a dedicated consumer.
Yeah, but at a higher level, is this for the chiplet or is this for a system and package design?
So yeah, chiplet both, right? Actually, so chiplet when it goes through the wafer test, so most of these are still needed.
So this would be information that would be used to, well, I guess the pin, just the pins are used to build the hardware, right? The wafer
Right.
hardware.
Right.
And then this is additional information that the test engineer would use to run wafer sort on the die.
Right.
Okay.
Yeah.
All right. So
But the long story short, Tony, like the actual consumers are the test program development guys. They would need to run to the pad guys, the pad development teams, or the physical design teams to extract all these informations. Some extent, uh, they might also go deep into the architect teams to identify what are the different corners are supported and which blocks are involved. Right.
yeah, so this information is being provided by the chiplet design team.
Right.
Yeah, and then it'll be used if you want to run wafer sort on the chiplet, which typically is going to be done by well, it's either it'll probably be implemented by if the customer if the design company has their own tester, they'll test it internally. They will develop their test program, but if it's going through an OSAT, then that chiplet company would provide the patterns to the OSAT for wafer sort. Now, it's possible, not likely, but it could be the system integrator who's buying the chiplet may also choose to rerun wafer sort. I think that's probably not going to be a standard model, because the expectation, if you're buying a chiplet, it's already pre-sorted.
Mm-hmm.
So how how would the system integrator who's building a system, 2.5 or 3D IC design that's using this chiplet with all this information, what would they do with that? How would they use this information?
Okay, so for the final package test, right? So even if they are not, even if they are relying on the wafer test information, the final package test, at least these pad characterization, at least some of the sample test has to be redone. Do you agree?
Yeah, but the package doesn't exist yet. This is just information for the chiplet, right? So
Yeah.
So you're going to assemble all these chiplets, right? So you're going to, put them all together, connect them. Some of these pins may be external and many are not, right?
Right.
So assuming they got this information for every chiplet, what is the system and package test lead? How does it use this information to, support the IO planning and develop a top level, SIP level test program? How is this information used? Is this?
Okay, so for the top level, again, as you mentioned, right, some of the pads are exported directly to the SIP package. So those cases, those partial scenarios will be directly applicable, and it can be like a, so it's more of a remapping this hierarchy from the chiplets to the package.
Right. So these pins need to be remapped,
Right.
These are, in general, they're all internal pins, right? And some, possibly all, but most likely not. Some of these pins are going to go externally. Some of them may get daisy chained to other chiplets, right?
Right.
So how, are we defining templates that?
So today we have the functionally these can, for example, any DFT patterns, there is a pattern retargeting kind of flow, which will remap the pins from the chiplet to the top level, and also will take care of if there are some more daisy chaining across the multiple dice. And so the tool will have that equal kind of a definition for each of those chiplets. So the retargeting flow will take care of programming those dependent uh, the middle die or the previous die paths, and then like offsetting if there is any pipeline.
So you're saying the test designer, the actual tools,
right? It's a retargeting tool, but that it takes care of just the function.
Would use this information for each of the chiplets to go off and, I guess, structurally defined the system level test structure, right? How everything gets connected, and what the primary inputs and outputs are, and how all these things are connected to each other. And those test tools, I mean, then, when you look at the assembled package, right, you all you have is external pins. You don't have any internal pins. So do we, there's going to be a set of balls on the package that's all you have access to, right?
Right.
To run the programs. So I'm just questioning how.
So okay, the first table, for example.
There's several companies that make DFT tools. So this is not EDA specific, these formats. We're just providing this general information. So do the tools, is it kind of a manual process where you're setting up the tools, you just specify all the pins, maybe write scripts that would get this information for each of the chiplets? And I'm just questioning how that process would actually work.
Yeah, so right now these are specified to the pattern translation tools. Like the pattern translation tools will have that the clock period definition and the input timing and the output timing windows, for example, in this scenario. So then the translation tool, when it reads the pattern database from the specific EDA tools, and then it can write out style or vehicle patterns with all this information. And so for your question, like so more of a scan, like any pattern retargeting kind of flow will transform all those information by reading in the zip level netlist and finding out the chiplet pins and the chiplet appropriate connected zip pins, and it will automatically modify the pin names for the upper hierarchy, and then which will also propagate the signal group period and this waveform sequence. All those information can be handled by the translation tool. Right. So, but these information, like for example, thermal and stress spec, this need not to be there in the TFT pattern as such, but this can be derived from the uh, from the data sheets.
Rajesh, do you have your hand up?
Yes.
Yeah, you have a question or comment?
Question. One focus question and one comment. First is a good work, Bala. This, if you can share, are you sharing that? Go to the parametric test. So I know you were interchangeably using DFT and the test. So I wanted to get some clarification from parametric test. I know you are developed the table for who is going to use it, targeted, but there will be also the people who are producer and the consumer, right? So
right.
For parametric test, who are the producing the test? Because I don't think it falls under DFT domain. It's like VIH and VIL test, right? We are talking about parametric test.
Yeah.
So normally, I mean, this may be my view, but since you had worked for Intel, it may be a different because every company has some. So who generates the parametric tests?
Okay, so
it is not.
the
I've not
DFT,
seen it from DFT team.
DFT they have a baby steps for the parametric test, like mainly to make sure that the sample preload and then the X test kind of instructions works appropriately. And so in Intel, you're right. Actually, they delivered a very minimal pattern, but it's and then the ATE guys, they expand for all the voltages and levels based on that initial baby step patterns.
Okay. So basically, DFT is involved only in HiZ and all that stuff, which enable the boundary scan.
Exactly.
Enables. Okay. I understood. Thank you.
Yeah. So that is also involving some of the corner cases, like with respect to the BSTLs, right? So Intel, for example, they have lots of modes, like there is a HVM and then there's non-HVM, and then there is a security aspects, right? And so there are specific BSTLs which comes along with the specific tap instructions to open up the security. So there are some preamble work is also needed. So there are lots of baby steps involved, and that requires.
Okay. I think the name of parametric got me confused because we used to call it boundary scan or in Broadcom. So that's okay. So my question is, this table should not only be limited to only showing the DFT pads, right? Because parametric test will be for all
you're right.
IOs.
Yeah. Right. It's for all GPUs and high-speed IOs. Yeah.
Okay. And the second, then we can, because then the consumer of that who is going to use this schema will apply it to entire chip IO.
Right.
Okay, and the second comment is, I know the pattern retargeting flow, of course, everybody is using for long time now. Every major EDA vendor has a pattern retargeting, but do you know by any chance that it has been extended to SIP level? System in package level? Because all Traditionally, typically, we have used pattern retargeting in complex SOCs where the cores come, core level patterns do not need to regenerate at the top. They reuse all the core patterns like USB core, HDMI core, and when they go into the big SOC, at SOC level, the entire pattern retargeting works fine because finally you have only one net list SOC level. But in system in a package level, has this tool been extended by any? Because they are now the different hard chiplets, right? So that's a completely different data. So has it been used? I mean, I don't know. That's what I'm asking.
No. Today, at least the Siemens, we have that scan, for example, any pattern retargeting, right? Which can be like from the partition to the SOC or partition to the, partition to the chiplet or partition to the stack level, like SIP level. There are
Yeah. So partition to the chiplet is what I know. It works. I mean, it has been used for a long time. I'm talking about chiplet level to SIP level.
Yeah, that's what I'm telling. Like, so when you want to do this SIP level, like you don't have to do 2-pass retargeting. You can, in Siemens, it supports the flow. You can directly take any partition and retarget to the SIP level. You can bypass the chiplet if you want.
I see. So that is outside whatever
that's a new tool enhancements with which understands the PTAP STAP stuff. Right? Before the tap, for example, MBIST patterns, pattern translation or generation does not understand the Alexa stuff. Sorry. So prior to the 1838, the tools does not understand multi-tap. Right? All it knows is single tap controller. And then there is a array of JTAG network, not the JTAG network, the TDR network under that. So now with the 1838 enhancement, it will understand the PTAP and the STAP.
Okay, then it should be supported by whoever the support 1838, it should be fun. But that is the very I mean, that's easier. See, MBIS patterns have always been easier to port at the top level because it just configured by the problem was with the scan.
Scan and bounty scan also now all the tools are supporting it. So
thanks.
I took an example where there was a classic scenario where many companies were asking the EDA teams to support the multi-tap structure because propagating the MBIST controller pins through the IEEE 1500 to the tab, like top level tab, it was always a bottleneck for the PD teams. So they have been asking to distribute the through the multiple internal tabs, right? But the tools were not supporting it. If you want to do any concurrent test across the tab network, so the tools were not supporting it for the test time reduction.
Okay.
Right?
Okay. So now one small comment. I mean, now I am in sync. So how do you see this, your current, whatever the schema you are showing right now is going to help in case of pattern retargeting? I mean, how is it going to help CDXML?
Okay, so today CDXML, we have few placeholder like a signal group and waveform and those type of things. So I'm giving more and more examples to give more possibilities to expand for the interoperability, right? And which is also given an example with different test characterization and protection requirements for the test program automations. It's not just the like a pattern generation, not into the DFT world or the ATE world also.
Okay. I mean, my thinking was it may be orthogonal. It may not directly impact the power of CDXML, especially pattern retargeting is concerned. But you may have some point. We need to think more. Maybe I'm not right now thinking in that pattern. Okay, that's fine.
Yeah. Actually, whatever
Thank
the
you.
question that you are asking is very relevant.
Yeah.
But just the recent tools they have made that announcements, the retargeting flows and things like that, but not everybody has like utilized, right? When we expose to different customers and get their feedback, and when somebody has some restrictions, they go out of spec, right? How do we support it, right? That's where the CDX schemas can come and driver play, like where yes, this will be a common methodology driver where if people not following the spec and it's not listed here. I mean to say this can act like an insurance for many standards. Maybe Rajesh, next meeting we can do maybe some deep dive onto the vector translation specifically. Like if I have overlooked something, we can bring some in offline also. But this you can view as an guidance for the ATE test program development.
Okay. So Bala, I have a couple of questions, starting from the first table.
Mm-hmm.
Looking at this, we do have the first column, the direction
Mm-hmm.
of the pin.
Right.
Now, what do you mean by a signal group?
So signal groups is it a name tag which is assigned for a clock, a reference clock, and for example, all the TDI, TDO, which will be aliased with the TCK, and all the data pins and the clock has to go with the same waveform table, right? One test pattern can have multiple waveform table, and so when the tool translates it, so it has to align the data when it is forced and when it is strobed based on the clock window, right? When it is cyclizing it. So that cyclizing information, which is tied based on the attribute name called signal group.
Okay. So here you have a signal group WFT tap, right?
Mm-hmm.
Which
Mm-hmm.
The way I understand it is you want to basically combine that clock pin with the corresponding strobe and data in and data out, right?
Right.
So
So
this is one group.
right.
Now you have the scan in, scan out, which is a separate group.
Right.
Does it not have a clock as well?
It will have its own clock. For example, this CLK. So okay, this you can say that this can be a WFT scan. So ideally,
Okay.
this will be two separate entries like this. Sorry, I'm changing it upfront.
Yeah. What I guess what I'm trying to understand is, can this one pin be clock for both tap and scan, or do you expect separate? I guess you.
Yeah, both combinations are valid. Like so, people sometimes merge the TCK and the scan. One of the and that same TCK can go to one of the scan clock, right? Uh, some cases, people does not want to merge it, and they want to keep it separate functionally, and so the both combinations of inputs are valid.
Okay.
Right. So like low pin count devices, they don't have a luxury of having a dedicated scan clock, for example. So they might reuse the TCK.
Yeah. Is okay. Yes. Is a reset for test different than functional reset, or it's the same reset pin?
Yeah, this is a shared functional and test reset. You can assume that way.
Yeah, right. So it's one reset pin that will
Right,
reset
right.
the entire device. You don't
Right.
expect to have multiple resets, right?
Yeah, that's again based on the pin availability and the how the designers are coming up, right? So ideally, reset need not be so complicated, but it can be single for sharing for the functional mode and test mode. But I have seen designs they have multiple resets like independently going. Like for example, data center kind of designs, like they have resets generated in different directions for the different functionalities, right?
Okay.
So CPU domains and the non-CPU cores,
Okay.
they work independent domains, for example. So
Okay.
um, so it's
So,
If
David,
yes, go ahead.
I think I can add what, because I've seen that sometimes it depends upon the software and safety system is end application. They do have multiple resets like a, warm reset or software initiated reset, SIR, and then hard reset just to get everything clean. So you might have two, but I think Bala is showing in one as just a placeholder.
right.
Yeah. No, what I'm trying to understand is my next question was going to be is, okay, if you have multiple resets, do you then expect some pins to be the functional reset, some other pins to be test reset, or would they be would test reset be reusing one of the functions? Right. Basically, what I'm trying to understand is, sorry, give me a second. What I'm trying to understand is if I'm thinking from XML point of view, right? I'm trying to understand how the tags would need to be applied on pins. That's all.
Okay, yeah. So this you can treat like a, for example, when you look at that SDC constraint, like so they have input delay and output delay of some magnitude, and that magnitude with respect to the reference clock of so and so clock pin, right? So this is something like that for the translation tool when they want to cyclize this pattern and force some values and sample some values from the input and outputs, and they need to give some reference clock, right? That reference clock for the translation tool is tied in the form of this attribute, so that there is no recovery or removal timing violation at the ATE itself when the pattern is applied on the tester. Right? It is aligned to the respective reference clock.
Okay. Yeah. Okay. Okay. Then my next question is in regards to these waveforms. Do you expect these waveforms to be voltage level dependent, or
Yes.
you expect? I mean, do you expect different waveforms, or do you expect some derating? The derating which you have. Do you expect that to be applied onto the waveforms, or do you expect a totally different waveform definition?
Okay, yeah, the waveform will be based on this sequence, right? Whatever the sequence that we specify when we do the vector generation or the translation. So vector generation can apply a clock period, for example, but translation can also follow the same thing, or it can even override to downsample or even go higher speed, right? Vector translation has that feature. Uh, but this is the spec, right? So you want to let's say I delivered the scan pattern for 100 megahertz, and in the ATA I don't find that my pattern are able to do shift through the 100 megahertz. So then through the ATE test method, there's a override, they can vary it, and that variable will be tied to this particular period wave variable, which is inside the binaries. Right. So that way they can change and override at different levels, like translation or ATE or pattern generation. So all those attributes are tied together for those respective tools.
Okay, how does that work for what is the flow? How does it work when we're talking about different voltages, right? If you're testing it, if you want to test kind of the same pattern, but at two different voltage levels, how would that work? You would
Even the voltage also, right? So there is a I had a placeholder for the each voltage, and then there is a placeholder for the period in terms of timing tools that they will have constraints. And where is that timing tools? Yeah, timing tool is also this period. But they have
right. Yeah. See, here's what I'm asking. Right, I do see the period. I do see the voltages. What I'm trying to understand is, what is the expectation? Do you expect to have different periods for
Yes.
different
So
voltage levels?
yes, yeah, it will be because you cannot expect a min SVS voltage to work at turbo speed,
Yes, of course.
right? So there is a like as we have like 5 to 10% voltage level differences from the min SVS to the super turbo. Like I mean, at each step levels. So there is a internal frequency. Also, there is a variation.
Right. Yeah. Okay. So
It's like so. People starts from 3.2 gigahertz when they reach to the super turbo. Yeah, both are there is a proportionate scaling factor is applied. It's not linear in
yes.
certain cases.
Yeah. Yeah. It's not, and that's why I'm so much into this. So, would you like to have a table that says, "Hey, this power domain at this voltage, this is the way for that voltage. This is
Okay,
the
yeah, maybe I can expand this table. Like so, right now I just put it as a one placeholder, and so nominal is a predominantly get go voltage, but then these are the other steps of the voltage. So I can put there is a voltage for each of those steps and also the frequency for each of those steps. I can expand that. Hello.
You lose David.
Yeah, we lost David. So he wants to, I think, expand, showing that an illustration for each of those steps, the voltage and the frequency levels.
sorry, Zoom kicked me out for a moment. So I missed what you said about.
Yeah.
Sorry.
So David, I think it is worthwhile to add both pair of information like a voltage and the frequency for each levels, right, across the min SVS, SVS, nominal, turbo, super turbo. We can just give an illustration of what is the voltage and what is the frequency range, right? We can just give some guidance.
Okay. Yeah, I need to think about that. In terms of expressing that, what is the syntax to express that, and what would be meaningful representation? Right. Okay. Okay, then you on the power domain, these are so you would expect the way I'm thinking about this is one would expect that okay, here's I think CDXML today, first of all, already has for each pin, it does tell us which is the relevant power supply. It doesn't. I think it's that way. I need to double check. But instead of specifying power domains and then applying power domains on things, the CDXML knows which are the power pin, and for each signal pin, it will tell us what is the related power supply, right? At the end of the day,
Right.
that's the golden information for the chiplet, right? It doesn't
Right.
matter. So one thing probably I need to think about is how do we enhance CDXML to tell us that, okay, for these power pins, which kind of act as power domains, what are the, how to enumerate the voltages for different modes, and then right, it's again it's related to the waveforms, right? If we're not really enumerating the voltages as value, but if we have the high level definition of a mode, maybe the waveforms need to be mode dependent. The only thing I'm kind of I need to think about is I don't want to get into a situation where we have an explosion of modes, right? Just for tests, if there's too many of them, or for functional, if there's too many of them, this is going to blow up, right? Especially if we have n by n kind of situation, right? We don't want to be defining 200 values for no reason.
Yeah, David, we're just about running out of time.
Yeah.
We be familiar with the Open Compute project, the test and validation work group, Workstream?
I have not attended that, but I know there is a work stream that's trying to do something. I'm not too familiar.
Yeah, so I met the guy who runs that when I presented at the OCP conference in this past spring in Dublin.
Mike Bartlett.
Yeah, and you're and David's names, you're and James's names were on that group, and
Okay.
we said we really should be working together. I mean, if there's a whole work stream working on tests, why do we have two different efforts within the same organization?
Yeah.
So I think yeah, I forgot to bring this up, but we did discuss this internally a couple of weeks ago, and I think maybe we should have a joint meeting with some of those guys.
Yeah, I think that's a good idea. And Rajesh, you used to attend that meeting as well, right? The you know, that work stream.
Yeah. So what was the comment, Tony?
Well, why do we have two different efforts in OCP that are both working on test and validation? I mean, should we
understand? Yeah, I mean this test work stream is. I don't see anything happening in this CDXML space there. It's a completely
well, what I'm saying, we have a collection of test experts. I think, you know, that is a proper work stream, and, you know, apparently they're doing quite a bit of work in that space. So at a minimum, we should let them be aware of what we're doing, and they can give us some more constructive feedback rather than, you know, we should be working together and not have two disparate efforts that are not even talking to each other. So so David, I think it would be good if we could reach out and set up a.
Yeah, let's do that. Actually, I'm thinking even simpler if maybe we should just show up at the next meeting for the work stream and just talk what they're doing.
Yeah, I don't want to hijack their meetings. We should probably reach out to Mike directly and just have a short meeting and
Okay.
then I think that makes
Yeah, and find out what's going on there and what we're going to do, and if we want to meet and talk about stuff and so on.
Yeah. Okay. All right.
Okay.
Very good.
Yeah,
Thanks,
yeah.
Norman.
Yeah, but let's continue on this next time. I need to digest this a little bit more after your description of the attributes and see if let's talk about it some more next time.
Okay, no problem. Sure.
All right.
Thank you.
All right, everyone. Thank you very much.
Okay.
Talk to you in 2 weeks about test. Next week is SIPA.
All right.
Okay.
Thanks.
Thank you.
Thank you.
All right, everyone. Good one.
Bye.